Hello, everybody, and welcome to HashiDays. Thank you for attending this workshop. We have some great content for you today. In this workshop, I will show you how to improve the resilience and the scalability of the various applications in your organization. I'll also show you how you and your service owners may gradually adopt service mesh benefits. How are we going to do this? In this workshop, we're going to touch on some of the common challenges you may face while designing infrastructure for resilient, scalable applications. Then we'll move through some of these solutions to help you meet these challenges. This workshop is for any of you interested in adopting service mesh in your existing infrastructure or learning more about the value of service mesh. You do not need any console experience to attend this workshop. This has been designed for anyone to benefit and get value from this information. All right, who am I? My name is Eddie Rowe, and I'm the lead product education engineer for the console team here at HashiCorp. Our team designs content for you to guide you along your learning and development journey. But we don't work in a vacuum. Our private education team is wonderful. Also, engineering and marketing have done a lot of work behind the scenes. They continue to be a wonderful group of people to work with, and I really enjoy working with them on their products. Also, now is a good time to say that if you have any questions throughout this session, feel free to post them in chat, and we'll do our best to get you the information or the clarity that you need. All right, let's get started on some content. My objective today is to show you how to gradually adopt service mesh with your existing services to build highly scalable and resilient applications. Using self-managed console, Kubernetes, and these other two technologies here, permissive mTLS and cluster peering, that we'll touch more on today. As a side note for the first two in this list, this pattern can be utilized with console on any platform. And that means Kubernetes, VMs, both self-managed console or HCP managed console. These are just the parameters for our demo today. Now we have some helpful links for you here. These are some external resources where you can get your hands on this workshop if you'd like to spin it up yourself and play with it. Also, feel free to check out all of our resources at developer.hashicorp.com/console. So, what's the deal with service mesh? What is the deal? The CNCF has tracked a large growth trend in service mesh usage in production over the past 3 years, with adoption continuing to increase year over year. This graphic comes from the CNCF's 2022 findings report. These percentages of service mesh, that's a tongue twister, service mesh usage in production come from Buoyant, Datadog, and Dynatrace, who collected anonymized data from the world's largest 15,000 organizations across all major industries, including financial services, retail, technology, transportation, manufacturing, healthcare, and public sector organizations. So a pretty wide and diverse group. With service mesh helping solve distributed computing challenges, the mesh is really only going to get meshier as time goes on. So now that you know a little about who I am and where we're going to go, this is a roadmap to how we're going to get there. We'll talk about some of the common challenges many of you face around console service mesh. Then we'll hop into a demo that shows how you can design scalable, resilient applications with console and provide a gradual mesh adoption experience to the various service owners within your organization. For some of you, this may be your first time hearing about service mesh, so let's demystify it. Here we have a classic model of service-to-service communication. It's the classic case of web service talking with API service, or an API service talking with the database. Now, the first core aspect of a service mesh is that rather than talk directly with each other, services utilize sidecar proxies to communicate. This is known as the service mesh data plane. You may think, hey, why do we go through sidecar proxies when I can just have services talk directly to each other? The answer is that sidecar proxies enable several advanced possibilities and features that allow you to boost the scalability, resilience, and security of your applications. And I'm excited to show you some of the latest in these features today. Now, the second aspect of the service mesh is the control plane. This is the value and the essence of console. With the control plane, you decide how traffic is managed, routed, and processed through your mesh. You decide which services can talk to each other, how they fail over to other data centers, and many more aspects of your mesh. In regards to which services can talk to each other, you control that with a console concept called intentions. These are configurable at layer 4 or layer 7, giving you complete control over service-to-service communication. So to summarize, the data plane moves the traffic and the control plane tells it how to move the traffic. All right, with that service mesh overview complete, let's take a look at how you can gradually adopt service mesh with your existing services to build highly scalable and resilient applications. Now, while the industry shows growth in service mesh adoption, let's not pretend it's a simple thing to adopt. Within each industry, there's organizations. Within each of those organizations, departments, within those smaller teams, this all leads to a huge amount of diversity in distributed computing systems. It also creates a lot of service owners with a lot of different opinions and a lot of different needs. Our teams have learned from interacting with many of you through conversations, surveys, and feedback. So let's talk about some of the challenges and themes that many of you have been facing around service mesh. One common challenge involves migrating services to the service mesh. Applications typically consist of multiple interdependent services that could be spread across multiple interdependent teams. Adopting console service mesh completely requires all of those interdependent services to be added to the mesh. Otherwise, services outside of the mesh will generally not have the mTLS certificates needed to securely communicate with services inside the mesh. However, we understand that moving every interdependent service into a mesh at the same time is a real challenge, especially when those services are owned by different development teams. Now, there are workarounds that have been in place for some time using ingress gateways. However, those workarounds generally add more configuration steps, complexity, and friction, negatively impacting the onboarding experience into the service mesh. So I'm excited to share that with the latest release of Console, we released the Permissive mTLS mode feature. Permissive mTLS mode essentially allows any non-mesh service to communicate with services inside the mesh. Now, there are some important requirements and caveats to consider when using this feature. One of those, and we can see these on the right, one of those is that permissive mode requires transparent proxy enabled. All right, we're going to hold up because this is some jargon that we're introducing right now. What is transparent proxy? Transparent proxy on Kubernetes or VMs allows apps to communicate through the service mesh without modifying their individual service configuration files. It essentially infers the location of your services based on name. Previous to this feature in Console, you needed to explicitly set upstream destinations in your service configuration files. All right, some other caveats here that gateways do not support mTLS modes. Routing non-mTLS connections through a mesh or terminating gateway is not supported. Intentions are also not enforced for non-mTLS connections. So with these caveats in mind, how do we implement and utilize permissive mTLS mode to gradually adopt service mesh? Let's hop into a demo and check it out. Party demo time. All right, let's dive in and get familiar with our current state of this imaginary Canadian business that we have. We have two service owner teams, front-end team and the back-end team. These together make up the incredible coffee as a service application, HashiCorp. In their shared single region EKS environment, the back-end team has adopted an integrated console service mesh. The front-end team isn't ready to fully adopt service mesh, but still wants to be able to communicate with the back-end services in the mesh. So how can the platform team empower these service owner teams? Let's hop into VS Code. All right, to accomplish this, we're going to enable permissive mTLS at the mesh level. This YAML file in the repo that we mentioned earlier is going to enable this at the mesh level. All right, yep, it's that easy. It went ahead and applied. Also, don't worry about memorizing any of these commands today. These are all available in the console docs for your convenience and in that link that we had earlier, and we'll also show that later in the presentation. The overall workflow that we'll do today is where the real value comes in. All right, now that we've enabled permissive mTLS at the mesh level, let's take a look at how this looks in the HashiCorp UI. So I'm going to port forward Nginx, the front end here, and hop on over to my browser. Okay, and I'm going to go to that port that I just forwarded, localhost 8080. All right, notice that it displays no products in this area. You can see unable to query all copies, check the console. The public API service right now cannot connect to the products API service. This is expected at this moment in time, but this isn't the ideal behavior that we want. The front-end services need to communicate with the back-end services for the entire application to function. So let's hop back into VS Code. To accomplish this, we're going to set permissive mTLS at the service level. I'm going to close this connection and move over to this YAML file here. And this is what it looks like. This is mutual TLS mode set to permissive for products API. So let's go ahead and apply this YAML. All right. So we've set that to permissive mode for products API. An important note here is that console intentions only take effect for mTLS connections. So at this stage, no intentions are necessary for public API to communicate with product API. All right, let's check back in with HashiCorp to see how this affected the application. I'm going to port forward this again, and then hop over to the browser. All right, hey, check this out. We are able to see some coffees in here, automatically refreshes, which means the front-end service and the back-end services are successfully connected. We're able to see these products now because the products API service can receive non-mTLS traffic from the public API service, effectively connecting the front end and the back end. And it looks like Canada has a limited selection. Only 2 coffees are available in this region today, but that's okay. Canada's happy with these 2 for now. All right. After the previous steps, we're now at this state. The dotted line on this diagram that you see here symbolizes the permissive mTLS connection between these two services that allow them to communicate. But fast forward a couple months and the front-end team has reached out and said, hey, platform team, we are ready to fully integrate all of our services into the mesh now. Oh, no problem, front-end team. We'll just update some annotations that will update each service's deployment. We're going to add this annotation to the 4 service deployment files that the front-end team is responsible for. These are the ones in gray on the diagram here. Those are the front-end applications or services. This will deploy a sidecar. When we update these annotations in each of these, this will deploy a sidecar proxy along each of these services that will allow them to integrate into the mesh. So let's go ahead and update these deployments with annotations. All right. I've created the updated deployment files with the proper annotations ahead of time. So let's look at the details in one of them. Let's go to Nginx because we've been in here before. Let's see if I can spell console right. There we go. Ah, perfect. Okay, so this annotation here, it was set to false or didn't exist previously for Nginx and the other 3 services. So we now have an annotation here. And what we're going to do is we're going to run a for loop on those 4 services that we mentioned that each have those annotations now. We also have some intentions in here that are going to allow a couple of these services to communicate with each other. All right. And there we go. Everything ran successfully. Let's clean up a little bit. Awesome. Now, at this point, there are still no intentions between the front end and back end services. We'll see more about that on the next slide. Once the rollout is finished, each respective service now will have a console proxy sidecar, effectively putting it into the service mesh. All right, let's go back to our slides and check out our diagram now, which reflects the state that each service has a sidecar proxy, symbolized by these pink circles. And they're effectively inside the mesh now. So we've harped on this a couple times, but remember how we talked about how intentions only take effect for mTLS connections. For non-mTLS connections, like between public API and product API here in the diagram, intentions are effectively ignored. So we have two more steps that are going to finalize the connection between the front end and back end services. This includes applying intentions that allow the service-to-service communication, and then changing the permissive mTLS settings at the service level from permissive to strict. So let's hop back into VS Code, take care of some business. All right. Let's take a look at what this intention looks like. It's going to connect the front end and back end. Here we have the source public API set to allow and the destination for products API. So we're going to apply this YAML file. There we go. Great. So now these two have the intentions to communicate. Finally, we're going to set the product API service to only accept mTLS. So I'm going to go back into another YAML file here. And remember, this said permissive on our other file that we had. This now says strict. And this is going to make basically the service only be able to communicate over mTLS. So let's apply this YAML. Excellent. Great. Okay. And let's hop back into our slides now that that's done. So the diagram here now reflects the state of our service mesh, where every service is communicating securely using mTLS. For maximum security posture and for cleanliness sake, for me, we'll disable permissive mTLS at the mesh level. Now, we just did it at the service level. Now we're going to do it at the mesh level to clean up. So it is important to note that disabling permissive mTLS at the mesh level will not affect the permissive mTLS settings at the service level. This is by design, as it allows any non-mesh services to continue operating as expected until they can onboard into the mesh. So let's go take care of this in VS Code. All right, let's take a look at that YAML file that'll disable permissive mTLS. Here it is. It said true before. This one says false. So let's apply that. And then also, I want to go check to make sure our application is still fully functional. So I'm going to port forward to the Nginx service. So we can go take a look at the application again. All right, let's hop over to my browser. And let's refresh the page. And there we go. We're all good. Application is still working as expected. Good stuff. Okay. So there we have it. A complete service mesh migration experience. Ultimately, this process using permissive mTLS results in a much simpler adoption experience that takes on less risk, since each service team owner can move into the mesh at their own pace, while still being able to communicate with any mesh or non-mesh service. Feel free to check out more about permissive mTLS on our docs to learn more about how it can benefit you and your team. All right, moving right along. Let's talk about another common service mesh challenge and see some cool stuff that you can do once all the services are inside the mesh. Now we're going to jump into how to improve your application and service resilience with Consul. We touched a bit earlier on the departments within departments theme throughout the industry. It can be challenging for you or your platform team to provide a standard, resilient networking solution to a diverse group of independent teams and service owners across your organization. We understand service owners already have an existing way of connecting their services. So for service owners to migrate to and stay on the mesh, the long-term benefits must overcome and outweigh the short-term adoption pain. So what are those long-term benefits and how can we achieve them? Some of the major long-term benefits for service owners are improvements in resilience and scalability. And there's a few dimensions to that we'll touch on here. The first dimension being of long-term benefits for service owners is in regards to resilience, which we can also think of as maximum uptime or high availability. Application failover scenarios are unique and situational from team to team, which creates a need for service owner-specific failover scenarios between Consul data centers. So how do you meet the challenge of service owner-specific failover scenarios? We can meet this challenge using a combination of Consul's cluster peering capabilities and Consul service resolvers. And today, I really want to focus on the theme of autonomy. The reality is that often in large organizations, Independent teams have made their own choices about cloud providers and runtime platforms. So cluster peering provides the flexibility to connect services across any combination of team, cluster, network boundary, no matter what the network topology or team ownership looks like. The other dimension that I want to touch on is scalability. Console administration operation is not always centralized, which creates a need for administrative and operational autonomy, no matter where the console data center lives, while also providing a platform team a centralized location for visibility and control of these console deployments. Kind of like a parent that wants to give their kids that feeling of freedom and independence, but they also want to have a sense of what's going on in the world. And we can accomplish this with the HCP Management Plane. HCP Management Plane provides you global visibility and control for both self-managed and HCP managed console clusters. It can do this with new or existing deployments. It can do it with VM clusters, with Kubernetes, and it supports both ACLs enabled or disabled. With these challenges covered, let's see how we can best design the mesh for resilience and scale in a demo. Demo time. All right, here's the current state of our application in console DC1 with HashiCorp fully operational within the mesh. The front end and the back end service owners have been very happy with the secure service mesh application in this AWS region. This is in Canada again. But since then, coffee as a service has become a critical resource and the business has grown dramatically. Executives have been given mandates to ensure that the service continues to operate without interruption in case a failure event occurs. Since then, the platform team has taken the requirements from the executives and created a replica, or close to a replica, of console DC1 called console DC2. This data center is a little different as it's in another region. It's in East US 2, and it's also with a separate cloud provider, this is Azure. They also spun up some console mesh gateways in each data center in preparation for making their application more resilient with console. Now, they're a clever team, as mesh gateways are used for data center to data center communication, and we'll soon see how they can be used in this scenario. This is now the current state of our HashiCorp infrastructure. 2 completely separate data centers in 2 distinct regions with 2 different cloud providers. Although both of these data centers are serving HashiCorp's traffic in their own regions, there's no cross-region high availability in this scenario. To accomplish this level of service resilience, we will peer the 2 clusters. So let's hop into VS Code, work through this process. All right, to begin the cluster peering process, we're going to modify the mesh gateway configuration in DC1 and DC2 to enable peering. You can see the YAML file here. Peer through mesh gateway is set to true, and we're doing a for loop for both DC1 and DC2. Perfect. All right, we have this set up in DC1 and DC2, so the mesh gateway is ready for peering. Again, don't worry about memorizing any of these commands today. These are all available in console's docs. All right, we're then going to set some default proxy behavior that are going to change how sidecar proxies communicate to entities outside of the mesh. This is called local mode for proxy defaults. And we're going to do this because the default behavior is that sidecar proxies make their own outbound connection. We'll do this in both data centers now. Local mode, rather than have the sidecar proxies make their own connections outbound, local mode configures sidecar proxies to utilize the mesh gateway for routing traffic to gateways in the destination data center. With local mode set, we're now going to configure a peering acceptor for DC1. Let's take a look at what this YAML file looks like. It's a peering acceptor, and it's the destination is DC2, and this is the secret that we're going to generate. It's a Kubernetes secret called peering token DC2. So let's go ahead and set that up. And I want to verify that it was created successfully. So let's check here. Perfect. The last thing that I want to check, I see that this is verified. I want to check to make sure that the secret that we just looked at there is generated. All right, great. Excuse me. So we've set up the peering acceptor here. This is going to accept peering requests from other data centers. In our case, in this scenario, DC2. And we have that secret that we saw that we're going to import into DC2. All right, we have the acceptor waiting for secure connections. So let's establish that connection with a peering dialer. First, import the peering token that we just generated. And then we're going to configure a peering dialer role for DC2. So let's take a look at what that looks like. Here's the YAML file. This is the DC2. It uses this secret and appears DC1. Perfect. All right, this is going to create the peering connection from DC2 to DC1. So let's apply this YAML file and create that connection. And the dialer's created. Awesome. Let me clean up a little bit here. Perfect. Okay. Our data center should be successfully peered, but let's verify. This long command here essentially goes into the console server container in DC1 and runs a command to check the peering status. All right, let's scroll up a little bit. And here we go. This is great. Yeah, we see active. The state is active for the peering connection. So we successfully peered DC1 and DC2. Let me do a little cleanup. Okay, awesome. That brings us to our current infrastructure state that we can see here in the diagram. We have 2 console data centers peered across regions and cloud providers, but we're not quite done yet. With the cluster successfully peered, the backend team is now ready to define their specific failover parameters. It's a priority for them that if the product API service fails in DC1, the public API service will seamlessly route to the product API service in DC2. The dotted peaking line here shows the desired failover scenario between these data centers and services. No problem, backend team. We can accomplish this with just a few touch points. So let's hop into VS Code and see how this is done. All right, our first touch point is making DC2's product API service available to DC1 as an exported service. So I'm going to click this YAML file. This is an exported service type. And it's for products API. That's what we're exporting. I'm doing it for DC1 here. That's our peer. So we're exporting this products API service in DC2 to DC1. So it's available there. I'm going to apply this YAML. Make sure I do it to the right data center. Excellent. Cool. Now let's confirm that the console cluster in DC1 can access that. And this is another one of those long commands like the verification one. So you can see I'm going into the server container for console and running a console command. And that's great. This is the expected behavior we're looking for. We see these 2 right here. We know that this is successfully exported. All right. For touch point 2, we're going to create intentions. So let's go on over to this intentions YAML file. These are going to allow communication from public API in DC1 to products API in DC2. Okay, and let's apply this YAML file, applying this to the DC2 data center. Perfect. All right, the intentions are configured and set. Touch point 3 is within the application itself. Now, our front-end team is highly aware of how their applications are configured. They've informed us on the platform team there's an environment variable, as you can see here, in the public API deployment that specifies product API's DNS address. Well, we're going to modify it. As you can see, I'm adding virtual.console here. Okay. That original one would only route within its current data center. This one will route to any data center where the service exists. So I'm going to apply this, and you can see here that the virtual DNS is successfully applied. Perfect. All right, so that's the application itself. Finally, we're going to configure console service resolver with a custom target of products API in DC2. So let's see what that looks like in our YAML file. Type service resolver. This is our target. Then there's our specifications, products API and DC2. So let's apply that now. Awesome. This completes all the steps necessary for this failover scenario. Clean up a bit, and let's head back into the slides. All right, we've arrived at the desired states. With service failover now fully configured in console and the application, the backend team is now ready to run through a failover test plan to make sure this whole thing actually works. We'll trigger a failover in product API in DC1 by scaling down the service. The expected behavior here is that public API will seamlessly route to the products API service in DC2. So let's hop back into VS Code and let's validate this failover. All right, to do that, we're going to scale down the service. Replicas equals 0 will do the job. And then I want to port forward to see how our application looks. Now let's hop over to a browser and refresh. Hey, it's still working. And in addition to seeing the previous DC1 service scale down, knowing that the application's working, the application lets us know about the change because DC2 has a way more robust coffee offering than DC1's when they only had 2 copies. All right, so let's clean everything up and bring it back into a healthy state. I'm going to set the replicas to 1 here. There we go. And everything should basically go back just to be in that region. So let's check. Let's look at HashiCorp again. And there it is, 2 copies. That's it. So we are back in DC1, the application. All right, I'll do a little cleanup. Cleanliness. All righty. Okay. Hey, improved application resilience in a cluster peering scenario. So we have 2 data centers today, but this coffee as a service trend, it's going global. Soon, we're going to have data centers all over the world. Cluster peering with service failover ensures your application resilience across data centers and regions. But we also wanted to provide the platform team a centralized location for visibility and control of these console deployments. Let's check out how we can do this with HCP Management Plan. All right. Go back to this window, and let's go to a browser, and we're going to visit portal.cloud.hashicorp.com. All right, and there's 2 places to get to where we want to go. On the left pane, I'm going to click this tab in the middle here under console. Then I'm going to click self-managed console, and at the bottom, link an existing self-managed cluster. I have a great naming convention that the executives totally approved of. So we're going to name this one DC1 EKS CA Central 1 and click continue. Now, this is basically the setup instructions that appear here. You can do this with console Kate CLI or with Helm. And there's a few steps here. We set our secrets to authenticate. We modify our values file with this configuration here for console. And then we're going to upgrade console to include those value files. And then when we're done, the page will automatically refresh. Okay, so let's copy this, and I'm going to modify this file. You may need to also. Basically, what I'm going to do is I'm going to add context here because that's how I Kubernetes between these different data centers. Okay, adding this stanza. I'll do it to the next one. So we can put it in one nice clean line. Add context here. Grab all this and put it into the terminal. Awesome. All right, 3 secrets are created. Okay, and I've already pre-created this. I put the stanza inside that we saw in the UI. I've already put it inside this file here, values dc1.hcp. So I'm going to do a console upgrade with this file as the target. Okay. Okay, paste this in. check if console can be upgraded. It can. And I'm going to scroll up here with console Kate CLI, and you can see that this is the only change, this stanza, in the console deployment that we have on this cluster. So I'll put in a capital Y to upgrade, and then console is going to start doing its thing here. And this may take some time, as if you have multiple console deployments for this step here. Now, the value over, as this is going through, the value over the current method that's in place is that doing this for each data center is going to create a single point of access for each cluster, as well as a cumulative overview for all your clusters. Currently, you may have public load balancers for each console deployment, or you may access each individual cluster via kubectl and port forward the UI. All right, looks like console's wrapping up here. Beautiful. All right, let's clean up a little here and let's go check out the UI. Hey, it did what it said it's going to do. It automatically updated the page, moved past those setup instructions. We can see our cluster here. We can also see these detailed services, service instance, sidecar proxies, along with TLS and the TLS expiration date, as well as many other details on here. And you'll have different details for the clusters here, but we're going to click this button up in the top right. It says Access Console. And this is the familiar console UI that many of you have seen before. Here's our services page. We didn't have to port forward at all. We're just clicking, on this option right here. We can see our intentions, create and manage intentions in here as necessary in the UI. And let's click on peers and check this out. This is DC2 that we're peered with right here. We can see the services that are being imported from there. So let's head back. Let's take a look at our overview again. Let's go back to our main page. All right, so we saw all these steps for DC1. Let's do the same for DC2. As you can imagine, we can basically do all these for as many clusters as we have. Okay, use that same naming convention that the executives approved of. Perfect. And it's going to generate those secrets and those steps again. Copy this, hop in the VS Code in a bit and change it. Again, it's going to automatically refresh after we've done these steps, like we saw previously. All right, I'm going to modify these. The right context here. I'm deploying this in DC2 this time. Oh, my formatting just changed on me. I don't know why, but I like the colors, so I'm going to go with it. Put that in there. Clean up the spaces in between. Grab all these secrets. And let's paste them in the terminal to get them set into DC2. All right, so we have the secrets. We're going to do just like we did before, but I'm going to change the parameters here to be DC2 instead. We have that file here with the cloud stanza added, just like we saw with DC1. So let's go ahead and upgrade console. And just to verify, these are the only changes happening in the console deployment YAML file. And press yes. We're proceeding with the upgrade. Allow console to go ahead and do its thing. Now, as these deployments continue to sprawl and sprawl and sprawl, and variety and nature has its way, and organic growth has its way, this allows a really streamlined process for accessing these clusters and operating and getting visibility. You can see which console versions that each of the clusters on. You can see the services in each. All right, as this goes through. Perfect. Console is fully upgraded. So let's hop back over to the UI, and there we go. Page is refreshed for us already, automatically did. We see the same details here, and we can click Access Console up in the top right. And here we're in this data center, and we see that we're paired with DC1. Beautiful. Let's go back to HCP. And I want to show you the global view again. Okay. Perfect. And here you can see the two services, the two clusters in this area. And as your clusters continue to grow, you'll be able to see your service instances and health. Lots of information in here. All right. So that's it. We've seen HCP Management Plan. Hey, so with this, as Coffee as a Service continues to expand to other regions, these patterns can be used to reduce risk and reduce complexity for both the platform and application teams. All right, guys, today you saw how you can gradually adopt service mesh with your existing services to build highly scalable and resilient applications with these technologies. You also saw how HCP Management Plan can provide centralized visibility and control of your console deployments. Feel free to check out our docs and get your hands on these features today. Here's some of the places you can go to dive into those features. The first one is the repository where you can get your hands on this lab. And the second one is our general landing spot for all console documentation. With that, we've reached the end of our presentation journey. Thank you all for your time today, and I hope all of you have a wonderful HashiDays experience. Have a good day.